Here's an inequality with an absolute value. It's an absolute value function. So the first thing I'm going to do is I'm going to look at my absolute value. Before I can solve this algebraically, I have to make sure that the absolute value is all by itself on one side of the inequality. I see that it's not. I see that it's having a number being multiplied to it and a number being added to it. So the first thing I want to do is I want to get rid of this 10. So I'm going to subtract 10 to both sides, because then I will have 1/11 times the absolute value of 2x minus 4, which is less than or equal to, well, 11 minus 10 is 1. Okay? So how did I know to subtract 10 and not to multiply? Well, remember, when I'm talking about the order of operations and I'm talking about solving, I'm going backwards. Okay? So solving, I'm going to look at anything being added or subtracted to what I'm trying to get by itself. Yes, 10 is being added, so I have to subtract 10 to both sides of that inequality. So now I'm looking at my absolute value. My absolute value is not quite yet all by itself. It's having something being multiplied to it. It's having 1/11 being multiplied to it, which means I need to turn that into a 1. And in order for me to do that, I have to multiply that by its reciprocal, which is the same as 11 or 11 over 1. It's the same thing. So I'll write 11 over 1 on this side, but 11 over 1 is the same thing as 11. So I have to multiply both sides, all terms, by the same thing. So I know that this divides out to a 1. So that gets rid of that. I don't need to write that anymore. So then that leaves me with the absolute value of 2x minus 4 is less than or equal to 11. Okay, so now I have my absolute value all by itself. Once I have the absolute value all by itself, I can now set it up into its two cases. I can set it up case 1 and case 2. So case 1, remember, that's the as is. Now when I'm saying as is, what's inside the absolute value just comes out exactly as is. Notice I haven't changed anything. Case 2 is the opposite. So I take the opposite of what's inside. So that's going to do the opposite of everything that's inside that absolute value. And so remember that this negative is the same thing as a -1. So let's go ahead and do case 1. We're going to solve case 1. So here, let's see here. I'm going to do PEMDAS backwards, which means I'm looking for anything being added or subtracted to my x term. So I have to turn that 4 into a 0. So this becomes a 0. Now I'm left with 2x is less than or equal to, well, 11 plus 4 is 15. Now to get the x by itself, I have to divide both sides of my inequality by 2. So that means I'm going to have x less than or equal to 15 over 2. That's one answer. So here I'm going to do the opposite. I'm going to distribute that negative into both. So I have -2x plus 4 is less than or equal to 11. I'm going to subtract 4 from both sides of the inequality, and I'm left with -2x is less than or equal to, let's see here, that would be 7. Now I'm going to divide by -2. because I'm dividing by negative, my inequality has to change direction. So that's my other number. So I was told to graph this. Okay? So if I remember, if I come back up here and I look at my original and I look at this inequality, I'm going to say to myself, the absolute value is less than whatever that number is, right? Just keep it simple. That means this is an and. That means when I graph it, I should have something that looks together. Let's see if that's in fact what I get. So instead of just blindly going ahead and doing that, we're going to graph it the way we have before, and we're going to look at what they share. Okay? So there is my graph. Remember, I have one variable, one line. I don't need to really worry about the exact values of this. I know this is negative, so negative number is on the left. This is positive, so I know a positive number is on the right. So x is less than. So less than numbers are always going to be to our left. And x is greater than this number, so greater than numbers are always to our right. So I know that it has to be where these lines overlap, and they overlap right here. So that means when I'm graphing this, because there's an equal sign underneath both inequalities, this is going to be a closed-in circle, this is going to be a closed-in circle, and my line goes in between. Everything in between. So x is in between here. So this is also another way of writing my answer like this. If I keep them separate like this, I have to write the word and in between the two.